So good afternoon. As always, I ask you for the last time if you can see the presentation and if you can hear me.
Good afternoon, Professor. Yes, we can see.
Okay. Okay. Thank you very much. So it's time to start. This is lecture number 21. The usual introduction about the material. I've simply uploaded the last lecture that was completely dedicated to your presentations. This is the last lecture, so no other appointments apart from the exam. We have 3 presentations today, and nothing to say about the exam. I would like just you to remember that the part 2 is scheduled for the 26th of May. So next week you are free especially to study for the second test, and the week number 21 we will have our second appointment for the second part of the exam. Then, as I said many times, you have many options during the official dates that are here presented on the right. I would like just to remember again that you can repeat one of the 2 parts if you are not satisfied about the mark. Or you can also ask me for other dates. Principle, if I am here in my office, we can organize 1 or 2 exams also during the week during the other day. The last important point that I would like to repeat is that if you are not satisfied with the mark, for example, of part 1, if you decide to repeat it, the first mark is completely deleted, so you cannot choose between the old mark and the new mark. No, the old mark, if you decide to repeat the exam, is cancelled, and this means that you have in any case to do it again and to accept the mark you will receive, even if it is lower than the first one, of course. Today there are 3 presentations at the end of the day, and we have to finish the last part of the program dedicated to coatings. Considering the presentations, just a quick check. We have 3 groups, group number 14, 15, and 16. If I've read the student present, I think that all the 3 groups are present today. Can you confirm, group number 14? Are you with us?
Yes, we are.
Okay, thank you. Group number 15.
Yes,
we are here.
There.
And the last one, Anita and Hakan, are you here?
Yes.
Yes. Okay. Thank you. So we can also close this. this presentation, and as I said, going on and finish the last part of the program, which was dedicated to coatings. Okay, so last time we have considered the first two parts, so the introduction, where we said what coatings material are, what are their advantages, their disadvantages. We said something also about the tendencies of the market, and we have also analyzed the market, and we said that the market still is dominated by the traditional solvent-based coatings, which are appreciated for many reasons. Today we will see why. But they present the big problem of the presence of volatile organic compounds, which, as we have already considered, can be dangerous for the workers. They can be dangerous for the environment, and can be also dangerous for the final users. The water-based the percentage is relatively high, but we have to consider that water-based coatings were introduced in the market, I can say, more or less 30 years ago, and the idea was that in the future of the coating operations would have been completely dominated by water-based. After 30 years or more, the situation is this. So water-based, they represent a quite big percentage of the market, but it is not enough in order to reduce the risks I've already mentioned, and that we will consider also today. Powder coatings, it's a very interesting technology, because we don't have any liquid substance in the formulation, but the problem is that we have to heat to high temperatures the coating material during the application. Normally it's around 150 degrees Celsius. So the problems with wood is that wood contains a lot of water, and if we hit its surface, the water can be emitted, and so the application could be affected by the release of water vapor, producing a very, very bad result. So we will see something about the possible use of powder coatings, just because it's a green option to cover the furniture surfaces, but as we will see on the other side, there are many problems with which are limiting the use of such products in the furniture sector. About the compositions, we said that the general composition of the coating is based on the solid substances, in particular some specific resins, which are the polymers which produce the the film, which can be completely transparent or completely opaque. In that case, we need some pigments, and in the formulation, different types of additives are used to enhance, to improve some specific properties of the liquid coating itself, or of the solid film after the application. And the rest is represented by liquid substances, which we have defined as solvents and thinners. The solvents play the function of dissolving the resin to make the system liquid, and the thinners are substances, liquid substances, which role is simply to reduce the viscosity of the product to make the liquid coating at the right viscosity for application purposes. The resins are different. We said acrylic, polyurethane, polyesters, epoxy, and nitrocellulosic, and many others. The type of polymer, it's evident, confer the specific properties to the final film. In particular, the resistant to scratch, the resistant to abrasion, the impermeability, the resistant to light. So this specific properties mainly depends on the type of resin which was chosen for the formulation of the specific coating material. All the resin must be soluble, otherwise we cannot produce a liquid coating. And then there is also in this case, as we have already considered in the adhesive world, this double option of thermoplastic and thermosetting resins. On one side, we have a good flexibility with the poor performance. I'm speaking about the thermoplastics. On the other side, we have better performances, but the film will be more rigid and less flexible as in the first case. We have simply considered some of the additives which are used in the coating formulations. The pigments in order to produce opaque coatings. And finally, as I said before, we have particularly analyzed the liquid substances, which role, as I said, is double. And in the case we said of solvent-based coating, the role of solvents and thinners is played by the same substances, which are volatile organic substances. And in the case of water-based coatings, the solvents are still VOCs, so volatile organic compounds. But in the thinners, so the substances which reduce the viscosity, in this case, are represented by water. So we have to consider that also inside water-based coatings, we have some volatile organic compounds, normally around 5%, between 3 and 10%. Which must be considered also for the safety reasons I have described before. Then we have consider the volatile organic compounds, the amount which is present in the different types of coatings, and the risks they represent when they evaporate in the working environment, when they evaporate in the atmosphere. We said that they, in combination with the oxygen present in the atmosphere, and in combination with the UV rays of the sun, they produce ozone, which is a dangerous gas. And we have also seen this map, but as I said, you can easily go on internet and find the values for the place where you live. And we said that especially in summertime, when the UV radiation is stronger, the values can represent a problem, especially in the industrial areas, or inside the big cities. For Italy, we have problems in Milano, or in Roma, and also in the industrial areas of our country, where the emissions of organic compounds can be very, very high. We said that there are limits. These are the references for Europe, and the final risk for VOCs is the slow emission inside indoor environment, because not all these substances are able to evaporate during the drying of the coating. Some of them remain inside the coating film, and they are emitted in our houses, representing a possible risk for our health. We know all the story of formaldehyde. In this case, the story is similar. The only difference is, in this case, the volatile organic substances are not produced inside the coating. They are simply a little residue of the coating operation. So they are emitted especially during the first period of the life of a finished product. We can say during the first month normally, and after this period, the emission can be practically zero. So the problem, the risk of the exposure to these substances normally can be relatively high. Only we said in new apartments, in new houses, or in restored houses, where, for example, the flooring was renovated, new furniture were placed. So in this case, we also can smell this odor of organic substances, which, as I said, represent a risk that is considered by some countries in Europe, France, Germany, and Belgium, and maybe in the next years there will be some regulations also for all the European Union, with some labels like the one you see here in all the product, especially of the building sector. That was all for the last lecture. Then we have now to go on with the classification of the coating materials. We can have two types of classification. The first one is based on the chemical composition or to the technological system which is used for example, for the drying of the coatings. We will see later what this means. But the classification is also functional because coatings they play different roles. So when the furniture surface is coated, normally the coating operation involves 2, 3, or 4 different types of coating material with different function. But we will see later this classification based on the function of the product. Considering the chemical and technological classification, we can have 4 different types of coatings. As you see here, the solvent-based, the photo curing or radiation curing, waterborne or water-based, and finally the powder coating. The solvent-based, we know already what this term means. These are coatings in which the resins are dissolved in volatile organic compounds, and as we said, this is a serious risk for the environment and for the people. We can have 2 types of solvent-based coatings in principle. 1 component or 2 components. In the first case, we have only 1 can, so we open the can and we can start to apply the coating. In the second case, when we speak about 2 components or 2 packs coatings, before the application, we have to mix the 2 components, the coating and the hardener. So in this case, when we speak about 2 components, we are speaking about chemical reacting resins. So we are in the presence of thermosetting polymers. Let's see what happened during the drying of the 1 component coatings. I've used this system where the solvents are represented by this violet circle, and the resin is represented by this chain of circles of green circles. I have used this system in order to avoid the use of chemical formula. So I hope this can be appreciated by my students. So what happened when after we have applied the coating? You can see. Sorry, I'm trying to use. Okay, this is our piece of wood, and this is the liquid coatings we have applied on it. So the resin molecules are floating inside the solvents. This violet part of the screen. So what happened after the application? The solvents start to evaporate, and the resin molecule they don't react. There are no chemical reaction among the resin molecules, but they simply come together. They come in contact, developing some secondary forces, as we already know, the van der Waals forces and hydrogen bonds and so on, but without any real chemical reaction. And finally, this process produces a coating film. Very simple. The process can be also very fast. So what are the advantages and disadvantages of such coatings, of nitrocellulose coatings, which still represent a big percentage of the coatings used in the furniture sector, not here in Europe in particular, but in other countries. The use of nitrocellulose coating is still very high. So the advantages are that we have only one component, so very easy to use it. As I said before, you simply open the can and start to apply. You don't have to carry out any preliminary operation. The drying is very fast. It's simply defined by the environmental temperature, and the final appearance is very good. It's a type of coating which is normally used, for example, for all style furniture. So the appearance is very nice. The transparency is very good. So normally it's appreciated in terms of aesthetic quality. What are the disadvantages? The high solvent content. We have already seen that nitrocellulose coatings can contain from the 70 to the 80% of volatile organic compounds. So if you apply 1 kilogram of nitrocellulose coatings, 800 grams are volatile organic compounds which evaporate into the atmosphere. So from an environmental point of view, they are really a disaster, I can say. You produce pollution, and the coating is the byproduct from a certain point of view. Because there is no chemical reaction involved, the mechanical resistance and the chemical resistance are normally very poor. It is sensitive to yellowing in consequence to the exposure to light and also to heat. And these nitrocellulose coatings are known for this possible blushing effect or defect, I could say. Blushing means that the film sometimes became whitish, like is milky, so not completely transparent. This depends on the high amount of solvents that are present in the coating formulation. So when they evaporate, they subtract energy from the surface. So the surface became cold. And what can happen if the relative humidity of the working environment is high? The humidity can condensate on the surface. So during the drying, some water can be incorporated inside the film. And so finally, the effect is this whitish effect, this milky effect. Remember that evaporation always subtract energy. So, for example, if you wash your hands with water, and if you move your hands quickly, you feel your hands becoming colder. This is because water evaporates from your hands, and during the evaporation, it subtracts heat from your hands, and so the temperature, the surface temperature of your hands becomes lower. This is the effect that you can experiment by yourself. So wet your hands and move quickly, and you will immediately feel the cold on your hand. So this is also what happened here, and the problem is that this effect is improved by the high amount of solvent which are present in the coating. So when this big amount evaporates, the temperature of the surface decreases a lot. And as I said before, if the environment is particularly wet, it's particularly humid, you can have this condensation of water inside the coating, and the result is a very, very bad optical effect with this reduced transparency and this milky effect in the film. We are still in the class of solvent-based coatings, and now we are considering the two components or two packs coatings. They normally are polyurethane or acrylic coatings. We have, as we can see here, resin. Resin which contains some oxygen and hydrogen groups, OH groups. Also in this case, the resins are dissolved in some organic solvents. And inside the other container, we have the hardener, which is a polyisocyanate hardener. So there are, as you see in it's a molecule, normally 3 NCO groups, which are very, very reactive, especially towards the OH groups. So these groups are looking each other, and they react, producing a new chemical bond. So when we apply the coating after the mixing of the two components, we have the resin and the hardener floating inside the liquid represented by the organic solvents. What happened during drying, as you see, some new chemical bonds are formed between the hardener and the resin, and this produces the cross-linking of the resin. So these groups can react with other molecules, producing the complete cross-linking, so the formation of this three-dimensional network of resin molecules. So, what are the good and the bad for this two components, polyurethane or acrylic coatings? The advantages are the good mechanical and chemical performance, and the reason is because there is a chemical reaction involved. So finally, we have a structure, a big molecular structure, which developed such good properties in terms of mechanical resistant to scratches, resistant to impact, and so on, and also good chemical resistance against liquids, cleaning products, wine, beer, and all the substances which can be in contact with the furniture surfaces. No yellowing if we use this aliphatic hardener. The disadvantages: the solvent content is lower than the previous class, but is still very high. Normally, the solvent content of such coatings is between 60 and 70%. So again, when we apply such coatings, we applied 1 kilogram and 600 from 600 to 700 grams are solvent which evaporate into the atmosphere. So again, the environmental balance is quite poor. So there is a lot of potential pollution, a lot of potential risk also for the workers, for the environment, and so in principle, such coatings should be avoided, considering the evolution of the market, the need of clean products, the need of green products, sustainability, and so on, as we have discussed many times during this course. The hardener can react with water and alcohols, and the reason is that these NCO groups, we said, is strongly reactive towards the OH group. So we know that water contains an OH group, and also the alcohols contain this group. So in the use of this type of coatings, we have to avoid the contact of the hardener with water, with humidity, and also with alcohols. They have to be completely banded when such coatings are used. The isocyanate is a very dangerous substance, so some precautions must be considered, especially during the application of such coatings. And here I've said exactly the opposite. No yellowing if we use an aliphatic hardener, and possible, and in some cases strong yellowing if we use aromatic hardener. You see the difference, aromatic and aliphatic. The problem here is that apart from this good property of aliphatic hardener, this type of hardener is lower, so the drying is lower if we use an aliphatic hardener, and also the final properties are lower, and the cost is higher. So the aliphatic hardener is good only because it's completely no yellowing, but all the other properties, the aromatic hardener is cheaper, is stronger, and it is faster. So normally the products, the hardener which are used, normally are in the middle. They are a mixture of these two hardeners in order to balance the properties that I have already mentioned. I think we have finished, yes. This is, I think, the most interesting type of coating from a technological point of view. The photo curing or radiation curing coating. They are liquid coatings which are converted into solid films by means of ultraviolet radiation or by electron beams. So the story here is more complex. Here we have resin, which contain several double bonds inside the polymeric chain. We have the solvents, which are a special type of solvent because they are reactive solvents. This means that inside their molecules there is also a double bond between two carbon atoms. And there is also an initiator. So there are three main components: the resin, the reactive solvents, and the initiator or photoinitiator. Here you see the coating, the liquid coating applied on our piece of wood. And in this case, we need a new ultraviolet lamp. We must switch on the lamp. And so what happened? The first step is the formation of radicals. Of radicals, because this is an example of this photoinitiator. Due to the energy of the ultraviolet light, this bond is broken, as you see here, and two radicals are formed. The radicals are very, very reactive chemical substances. In particular, they can react with the double bond of the resin molecule or with the double bond of the reactive solvent. So this is the first step, is the production of radicals from the photoinitiator. Then the second step is the starting of the chemical reaction. Involving, as I said, the double bond present in the resin molecule, or the double bond present in the reactive solvent. So the radical reacts in this case with the resin, and a new radical is formed on the resin itself. So this again can react with another resin molecule or with another molecule of reactive solvents, and so the process goes on, involving all the resin molecule and all the reactive solvent molecules. So finally, many new bonds are formed involving the reactive solvents and the resin, producing a complex 3D network, very strong, which, as you see, does not present the problem of emission, because the reactive solvents react with the resin, producing itself the final coating film. So, in principle, among the advantages, we can see the very high solvent content, which can reach the 100%, so no emissions in the atmosphere. Very fast drying, because after the coated element, after it passes under the UV lamp, after a few seconds the drying is completed. So very fast, and very good performances in terms of mechanical and chemical, because of this high cross-linking involving the resin and the solvent. So in terms of performance, we can say that this type of coating is the best, is number one inside the range of furniture coatings. Disadvantages, we can consider that what is chemical reactive normally is also dangerous. So this reactive solvents are very good because they don't evaporate into the atmosphere, but we have to take special precautions during the application and during drying, because they are really dangerous for the workers. Normally the viscosity of such coatings is very high, so the application can be done only with special system, for example with rollers, not with spraying. This is the most important disadvantage for this kind of coating. They are not suitable for 3D objects, because it's quite clear that if you have flat surfaces you can have an UV lamp placed here, which is able to irradiate all the surface very, very easily. But the problem is when you have, for example, a chair. If you have a chair, it's a 3D object, and it's practically impossible to reach all the parts, all the surface of a chair, considering the internal part, the back and the forward parts, so the lateral surfaces. So in principle, it's possible to use this technology also for 3D objects, but in practice is very difficult, because we have to arrange the lamps in a very complex way in order to reach all the hidden angles of the object you are producing, you are coating. So this technology is very good for flat surfaces, but not so much for 3D objects. And the other problem is that it's okay for transparent coatings, because the UV rays can penetrate inside the transparent coatings until the internal layers. But if there are some pigments in the middle, the penetration of the coating is affected by the pigments, and so for highly pigmented coatings, there are some problems. So it is possible to dry also opaque coatings, but normally the film thickness must be not so high, and also the content of pigments normally must be reduced. So it is possible, but with special precautions, with special also initiators, with special lamps. So it's possible also for pigmented coatings, but with some differences in terms of formulation and also in terms of plants. I've not written here among the disadvantages that one disadvantage of such coatings is the high cost of the coating itself and also of the plant, of course. Waterborne, in this case, we have already seen that we have the raising, which is not dissolved inside water, is dispersed. I don't want to repeat here what are dispersions. This is an image of what is we can imagine the dispersion of the erasing particles inside the water medium. So the drying must consider that the raising particles are not dissolved inside water, but they are dispersed. So we have the raising, we have water, and we have also this organic solvent, which is normally known as coagulation. So what happened during drying? Water must evaporate initially, And when water is completely released, the solvent start to open the resin particles, so acting as a normal solvent, and so allowing the resin to merge together and to form a proper film. So you see here this opening of the resin particles, and finally also the correlation must evaporate from the film. Also for waterborne coatings, we have 3 types of products: the 1 component, 2 components, and UV curing. The advantages in all cases is the reduced VOCs, and for the 2 components and UV curing, we have the improved mechanical and chemical properties. Among the disadvantages, we can see some pictures. One of the problems we have with water is the sensitivity of wood toward this substance. So we know that the problem of the swelling. So you see that this is the wood surface before the application of the coating, and this is after the application. You see that some wood fibers raise up simply because they absorb water, and then they swell, as we know very well from all the stories we have already considered. So if you want to use water-based coating, you have to treat very well the surface before the application of the coating. So you have to cut all these fibers with special sanding papers before the application of water-based coating. Otherwise, the effect, the visual effect, would be affected by such raising of the wood grain. The surface tension, we already know what is the surface tension. For water, it is higher than the surface tension of other organic solvents. So this surface tension prevents water to enter inside the porosities of wood, and the final effect can be a surface like this. It seems the surface of the moon, simply because, as I said, water, because of the high internal force, the high internal cohesion, it doesn't easily fall inside the wood porosity. So again, this disadvantage can be considered. And for example, in order to reduce this effect, you can simply heat up your water-based coating, because heating the coating means to reduce its surface tension. So by simply heating the coating to, for example, 25-30 degrees, you can easily avoid this problem. But you must know the problem, and you must know also the possibility to reduce it. So to avoid this, good sanding. To avoid this, don't use water-based coating if they are cold. The drying, the latency of evaporation is the energy required by 1 gram of liquid to evaporate, and you see that the energy required by water is 5 times, 6 times higher than the energy required by organic solvents. So what does it mean? It simply means that this solvents can evaporate also in cold environments because they are able to subtract this energy from the air. In the case of water, if the environment is cold, water is not able to subtract this big amount of energy from the air, and so you must buy a drying system, drying oven, if you want to use water-based coating. In the case of solvent-based, you can switch on or not your drying system, and the evaporation is good in any case. In the case of water-based coating, you need a drying system, you need an oven, and you must always switch on it in order to properly dry the coating. Another problem with water-based coating is the relative humidity. When there is a climate with sun and with low relative humidity, the drying is very fast. If the environment is full of water, the drying, the evaporation of water is really slow. Here you see some data of an experiment we carried out in my institute some years ago. The first is a solvent-based coating, and we measure the drying time with 3 different relative humidities, always at 20 degrees. And the time you see here is always the same, so there are no effects on the drying time for solvent-based coating, 7 minutes in all cases. If we use water-based coatings, we did the experiment with 3 different coatings. You can see that at a very low relative humidity, the drying time is relatively fast, around 15 minutes. If we improve the relative humidity to 65%, the drying time increases, and when we reach 85% of relative humidity of the air, the drying time of water-based coating is very, very slow, taking from 40 to 50 minutes. So again, in the case of water-based coating, you must use an oven, and maybe it's better to control not only the temperature but also the relative humidity. So I normally say that water-based coatings are not much appreciated by the furniture manufacturer because they don't know them. If they would know the story of grain raising, the story of surface tension, the story of drying, the energy required, and the story of the relative humidity, they would better use such coatings, and maybe they could substitute solvent-based coating with water-based coating if they know how to use them. The problem is that sometimes they try to change using water-based coatings in the same way they were used to use solvent-based coatings. They see a bad result and they say, okay, let's go on with solvent-based. If a little culture could be given to the furniture manufacturers, I think that this percentage in the use of water-based coating could increase, simply because they could know how to use them. The last type of coating materials is represented by powder coatings. So they are supplied in the form of powder, as you can see here on the right. They are melted, applied, and finally the curing can be thermal curing, or again by the use of UV radiations. I think that here there is an interesting video presenting an UV powder coating line. MDF are used in this case. You see the initial preparation of the elements on the conveyor. The first step is the heating of the surface with IR infrared lamps. So the elements enter inside this and here you see the application of the power. So there is the initial preheating with the IR lamps, and then the application of the power, which practically melts on the surface of the MDF panel. Then again, the panels enters in this tunnel with UV lamps to complete the drawing, to complete the cross-linking of the coating. So it's a very fast line. Only one application which is able to cover all the surface of the panel. No emissions in the atmosphere. So in principle, is a very good option in principle. So okay, what happened? Okay. Okay, sorry. So no emission of volatile organic compounds. So it's a clean technology. The powder which does not reach the elements can be recovered. So We have no overspray, so all the coating all the powder is really used. So 100% of the application. No residual of coating to remove, to clean. High thickness in one coat, and as we have seen, the application on both sides can be carried out in one single step. So very, very good in terms of advantages. Unfortunately, the disadvantages are very, very serious. We need a very high application temperature, and this produce the release of moisture from the surface of the panel. So this is the reason why we can use only MDF panels, because they are homogeneous, because the moisture content is normally lower than for woods, and the release of water can also produce the possible deformation of the substrate. So for this reason, we can coat only high thickness panel. We cannot coat 2 or 3 millimeters MDFs, because we will surely find some deformations caused by the temperature. And finally, the leveling is not good. We cannot produce very, very glossy and flat surfaces. Normally, the surface is not very flat, very homogeneous. So for for certain markets, the quality, the appearance is not acceptable. There are some productions which are also sold considering the environmental benefits of the use of powder coatings, but the aesthetic quality is very, very poor, and I can say that it's a little market, especially for those people who are interested in buying ecological products. So they are more interested in ecology than in aesthetics, and at the moment, unfortunately, this market is very limited. Very quickly, we said that we have this chemical technological classification, but there is also a functional classification. So very quickly, there are some products called stains, which are simply products which as I wrote here, ennobled, or we can say change the color of the surface. You see that you can apply a stain in order to produce a reddish surface, a yellow surface. So with the same wood, you can produce different shades for your different purposes. So very often the first application in the coating system is the application of the stain to change the color of the wood substrate. In some cases, we need to apply the products called primers, which perform some specific functions, like, for example, to improve the surface energy in order to allow a good adhesion of the following coats, or some for specific substrate, they can be applied to prevent cracks or to reduce some possible defects, like the possible whitening of the pores due to the difficulty of some coatings to penetrate inside the porosities of wood. So primers are special products which are used for specific reasons on specific substrates. The base coats are the products applied in order to create an homogeneous layer before the application of the top coat. In some cases, we can also apply more than one coat, especially when we want to produce very flat, very also glossy surfaces. For example, if some of you play the piano, you know that the surface of the piano is very glossy and very stable. In order to produce such effects, in some cases also 10 different layers of base coat are applied in order to create this very flat and very stable surface, also which maintains its stability also during the years. And finally, the top coats, which are the coats which are visible by the end user. So and also they represent the layer, the external layer, which confer the main properties, the main performance to the final product. In some cases, such top coats are also added with special substances like waxes or silicones in order to create what is known as soft touch effect. So this nice sensation you have when you touch the surface of a furniture element, especially for high quality furniture. The manufacturers they are also interested to this sensation, this soft touch sensation when the surface is touched. So if you have the possibility to visit, for example, an high quality furniture manufacturer, try to touch the coated surfaces, and you will feel this nice sensation, this soft touch effect, which represent, as I said, an interesting properties for high quality products. So the surface are not only appreciated by our eyes, but also by our fingers. Operational aspect, very quickly. I don't want to stress you with such a part, just to see how complex is this sector. There are some pictures here. You see. The application system completely automatic on the top, and UV ovens, UV tunnels on the bottom. We have rollers, we have coating coaters. Here there is a short video to show to you what is a coating coater. Here in the middle, this part is the coating. It's like the coating of liquid coating, and so the panel passes under it, and it is immediately coated. So very quick and very precise. Okay, so this is there are spray guns of various types installed with complex machines with different movements in order to be able to coat all the panel surface. Different drying tunnels with air jets, like in this case. Hot air tunnels, vertical ovens which play different functions, tunnels with higher lamps and microwaves which can be used only for water-based coatings. UV tunnel with different types of lamps. The last development is the use of UV LED lamps in order to save energy. This is very interesting because the old types of lamps, the problem was the high emission of infrared light, which it's simply hit the surface. In the case of UV LED, the light is completely cold, so no heating effect that can be problematic for such coatings. My goal was to finish for 2:30, and so my goal was respected. So we have finished also the part 6 of our program. If you are still alive, I think that we can now have a break. I think 15 minutes, so we can meet again at 14:40, and we will listen for the last 3 presentations. Okay, so right. So okay, so. Is there a question?
Yes. And Anita and me are groups, and can we present first?
If there are no objections for the other groups, for me it's okay.
Okay, because I have to catch the train. If it's okay for everyone.
Okay.
It can be better for me. Yeah.
Okay. No objections. So you will be the first.
Okay. Thank you.
Okay. It's all right if we meet here at 14:40.
Okay.
Okay. So let's go to have a coffee.
Okay. See you.
Okay. Thank you.
So, okay, we can start this last part of our course dedicated to the final 3 presentations. I think that the first group is that of is group number 16, if I'm right.
Yes, Professor, here.
Okay, so can you start?
Okay, but I need to call Anita. Just a minute.
Yes. I will share the presentation now.
Okay. And the presentation is about bio-based alternatives to formaldehyde in wood-based panels.
Yes.
Yeah.
Okay.
Professor, there is something wrong with my camera for 2 days. Is it problem?
No. It's important to see the presentation and to listen to you.
Okay.
Okay. Can you see the
Sorry,
presentation?
we cannot see. Okay. Please start.
You can see the presentation in presentation mode?
Yes.
Okay, thank you. So today I'd like to discuss with you, together with Akan, about the topic of bio-based alternatives to formaldehyde in wood-based panels. So let's have a quick overview about our presentation for today. First of all, we want to present you our idea, so why we have chosen this topic. Then we will switch to a short introduction explaining you what bio-based adhesives are and something about the history and so on. And at least we will focus on some types of bio-based adhesives. In particular, we will focus on soil-based adhesives and starch-based adhesives. And of course, we will finish our presentation with some conclusion. So, you have seen in our materials and technology course that formaldehyde-based resins are used for wood-based panel manufacturing. And we have also seen that wood industry are the highest users of adhesives. So just for give you some data, 65% of adhesive are used in wood industry. About the type of adhesives that are used, 92% of the adhesive used in Europe by the wood industry are urea formaldehyde. So that 11 miltons of urea formaldehyde are used every day worldwide. Urea formaldehyde is the most used adhesive because, as we have seen, it has a lot of good properties. It is low cost, it has good bonding properties, but as we have seen, it also has a big drawback, that is emission, formaldehyde emission. And we have seen that formaldehyde has been categorized as cancerogenic to human, and this is why we decided to search in some solution about this problem. We also see something about it during our lectures by Professor Boulian. For example, we have seen that the use of scavenger has been investigated. But for this presentation today, we decided to focus also on another aspects, that is the lack of sustainability of urea formaldehyde-based adhesives. In fact, synthetic adhesives has a high environmental impact. They are not biodegradable completely, so they can lead to waste accumulation and so on. And this is why we decided to focus today on bio-based adhesives. Just for give you some other information, a little curiosity, some life cycle assessment comparative analysis has shown that urea formaldehyde adhesives has the 22% higher environmental impact than bio-based adhesives. In particular, in this study, they were studying lignin-based adhesives. So now you all know why we have chosen this topic and why this topic is so relevant. So we can switch to a short introduction about bio-based adhesives by Hakan.
Thank you, Anita. I will give general information about bio-based alternatives. Some materials obtained from natural resources can be used as materials for the production of wood adhesives due to their ability to bond with different elements. But this is not new finding. In fact, the use of additives in wood products dates back Egyptian, Greek, and Babylonian civilization, where additives were made of blood, bones, hides, vegetables, eggs, and milk, which contain starch or proteins as binding agent. Then soy-based additives were used extensively for wood composite manufacturing from the 1930s until 1960s, when petroleum-based additives replaced them on the market due to their low price, better additives properties, and water resistance. But we have seen that between all these properties, there are two consistent drawbacks that are the emission and the lack of sustainability. By searching in the previous literature, I have found that a lot of different types of bio-based alternatives to formaldehyde resins have been studied. For our presentation, we will focus mainly on two of them. First, soy-based alternatives and the other starch-based additives. But in our references at the end of the presentation, we can find a lot of information about all of them. Now, Anita will talk about soy-based additives.
Okay, here we are. First of all, we want to explain you why we have chosen to talk about soy-based adhesives. We think that soy could be the ideal raw material for bio-based adhesives. In fact, it is low cost, easily processing, and it also has a quite high content of protein. And we know that protein has a key role in adhesive strength. In order to produce our soy-based adhesives, first of all, we have to choose the raw material. We can choose between three raw material. We can choose soy flour, soy protein concentrates, and soy protein isolates. And we will choose one of them according their properties. Soy flour has the lower cost, but it has also a low protein content. Soy protein concentrates has a higher content of protein, around 70%, while soy protein isolates has the highest content of protein, but they has also the highest cost. So once we have choose the raw material, we have some problem to overcome. The first problem is water solubility. In fact, we know that proteins are formed by amino acids, and if we look into soy protein molecules, we will find 18 different types of amino acids with different properties. These amino acids make the protein be soluble in water, and this is why unmodified soy protein are not so suitable to be used as adhesives, especially in wet environment. The other problem is viscosity. In fact, as we have seen in our course, high viscosity is not a good properties for adhesives because it brings to a lack of spreading or penetration of the adhesives into the material considered, that in our case is wood. Why soy protein has this high viscosity? They have a highly ordered structure and with these strength bonds that make it be so viscous and not so suitable to be used as adhesives. Are there some solution about it? Yes, we have some solution, and we decided to discuss with you about denaturation. Denaturation is a process that involves the breakage of bonds within the molecules. By breaking these bonds, we will have a reorganization of the molecules with a consequent change in these properties, that in our case, the property is water solubility. And we will also have an increase of the degree of disorder inside the molecules that will bring a lower viscosity. So thanks to the denaturation, we can overcome, we can say, the two previous problems that I present. How can we do denaturation? We can use both chemicals or thermal treatments. For chemical treatments, we can use acids like sodium hydroxide, we can use alkalis or salts. We can use one of them or more of them in combination, we can say, according to the degree of denaturation that we want to reach. And then we can use thermal treatments. They are the most used and the most common because they can be used as a single treatment, but they can also be used as in addition, we can say, to other treatments if we want to improve the degree of denaturation. So now I think that all the steps for the production of our soy-based adhesives are quite clear. So we can switch to the starch-based adhesive by Akan.
We decided to talk about starch-based additives because starch is an abundant, inexpensive, renewable, and biodegradable polymer. It is the second most abundant natural polymer after collapse and can be obtained mainly from the roots, stalks, and seed of stable crops such as rice, corn, wheat, tapioca, and potato. In order to understand why starch can be used as bio-based adhesive, we must do a short introduction about its structure. Structure is the mixture of two distinct polysaccharide fractions, amylase and amylopectin. Both are composed of glucose with different size and shapes. So, as we have seen for Kellos molecules, glucose means OH polar groups. That means the possibility of form new bonds. So we can say that strike strength is the hydrogen bonding forces that allow to obtain strong adhesive forces, but this characteristic is also its weakness, since they also easily form hydrogen bonds with water molecules, leading to poor water resistance. Therefore, it is necessary to modify structure in order to increase its performance before using it adhesive. But how can we do it? First, cross-linkers. We have already seen what cross-linkers are when we studied chemical treatments for modified wood during our course. Also, in this case, we can use some cross-linkers agents like glycogel in order to increase water resistance. And second, acids. Some kinds of acids, such as citric acids, borax, sodium, hypochlorite, can be utilized as oxidizing agents for structure, and it was found to reduce the moisture sorption, the molecular movement, and swelling at high relative humidity. Third, emulsion. In order to produce adhesive with higher properties, we can also a mixture of structure and natural rubber laid, that is the white sap that comes from the rubber tree. And last, biopolymer. At least we have a biopolymer. By searching in the literature, we have found that protein struct composite and tannin struct composite can also be used for wood and wood composite adhesive, which is eco-friendly system with zero formaldehyde emissions. So as soon as conclusion, we can say that for sure UF has good properties. And to sum up, we choose this subject because we saw that formaldehyde-based resins are traditionally used as binders in the formulation of wood-based panels. And we also learned in our lessons that wood product manufacturers are the biggest users of adhesives. We want to deal with the issue in terms of sustainability, as it will be more meaningful for today's research. That's why we decided to talk about bio-based adhesives for wood-based panels. In this presentation, we focused on two important issues. You can check our references for detailed information. We will focus mainly in two of them: soy-based adhesives and extract-based adhesives. First, soy is an ideal raw material example to produce wood adhesive due to its low cost, high protein content, and easy processing. Three different types of raw material can be used to produce soy-based adhesives. These are soy flour, soy protein concentrates, and soy protein isolate. After selecting the raw material, there are two main problems you need to work on obtain soy-based adhesives with good proteins. These problems are water solubility and adhesive viscosity. However, the nature method can be used to solve these problems. The narration can be done by different types of process, which allows us to achieve different results, chemical and thermal treatments. Secondly, structure is an abundant, inexpensive, renewable, and biodegradable polymer. Struct can be used as bio-based adhesive because it's mixture of two different polysaccharide fractions, amylase and amylopectin. Environmentally friendly Struct adhesives can completely replace UF adhesives in wood and wood composite application. And that's end of our presentation.
Yeah, we have some references for you if you want to learn something more about bio-based adhesives. You can find all the information here. And thank you so much for your attention. If you have any question, we are here to answer to you for sure.
Okay, thank you, Anita, and thank you, Hakan, for this presentation. In principle, it gives some interesting ideas about not only the reduction of formaldehyde emissions, but also about this path toward the sustainability. This is something that we must always take consider in our minds. Other questions from the students? No. What can you say about the use of such adhesives in the industry? Because you presented the base, something about the theory, what must be done in order to start from soy and to derive the adhesive. But do you know if they are already used in the market in some applications, in some
Yes.
furniture? No, sorry, the panel manufacturers.
Yes, we have found some information about it. Some industry are already using this type of bio-based adhesives, especially soy-based adhesives. I just want to share another time this presentation. If you are interested about the use case of soy-based adhesive, you can find a lot of information in this paper. Here, a lot of practical use of soy-based are explained, and also with the industry which are using this type of adhesive are mentioned here in this one. So yes, they are used up to now. They have been used also in industry.
And the same question for Hakan. What about the starch-based adhesive? Did you have you find some real applications?
Yes, I mean, let me show it. Do you mean, do you want to know the real application about this?
The starch base, because Anita told us that soy base are already used, and I can confirm that because I've seen some plywood produced with soy base adhesive. It's quite new also for me, the use of starch based adhesive in the panel industry. So my question was, have you some information about the real use by the industry?
I can't give you a clear answer about this real example.
Okay.
I can add some words about it. Soy-based adhesives are more used also because they were used in up to 1930. They were used, while for starch adhesives we are still in a research phase. I can say you that some research has been done with a mixture of starch and tannin. Adhesives, but for starch, yes, we are still in a research phase, we can say. Soy is most used also because it's like we can say more suitable for this kind of application.
Yeah. Okay, thank you. I don't see other questions coming from the other students. So, okay, it's good. We can finish here your presentation if there are no other questions. And we can move on with the second presentation, which is number 14, I think. So I would like to thank again Anita and Akan for their presentation. And I will let now the floor to Ronia and Tom.
Thanks.
I see you.
Yes.
Okay.
Tom has to share the screen. Yes, I think this is perfect. Yes, welcome also from our side to our presentation about wood plastic compositions. We are basically focused on the finished products and yes, the biodegradation. In the next slide, you can see the agenda. Yes, first of all, we are starting with the basics as a small recap. Then we have the usage and the market size and also some products, and at least we are going through the biodegradation of these wood plastic composites. And yes, starting with a small definition. As you could see, this is one of several definitions, but I think this is the most common one. Therefore, it's very important to know that these wood plastic compositions, short WPC, is thermoplastically processable composites, which have three different main components, that is wood, plastic, and additives, are more or less produced with extrusion, injection molding, and pressing techniques. To go more in detail to the different composition materials, next slide. There we have the polymers. This could be the synthetic and the biopolymers. The wood, it could be fibers, fluors, and wood chips, and the additives. As you can see, there are this percentage behind the different additives, the different composites of the material. This means that is the very huge range of these different parts. So you have so many kinds of mixtures of this material. For example, you could have 50% of polymers, 40% of wood, and only 10% of additives. So this is very important to know. In the next slide, I give you a short historical recap, starting in the 1960s, with the first start of the modern WPC. Then we go to the 1960s, where German and France researchers give this first kind of this Winnepol process, and then go through the 1970s, where this Italian company get the first mixture with 50% of wood, and end at the 1990s with the more or less biggest part of using WPC in various sectors. Then after that, in the next slide, we need to know why this material is so interesting. This is based off the connection of two very different industries. First of all, we have these processing techniques of the plastic industry, like extrusion, injection molding, and pressing techniques. But in all of these procedures, we have the properties of the material of wood. So we have all the time a varying quality. We have the moisture and dust problems, and also we have this processing temperature from wood. As you may know, the processes out of the plastic industry are in a lot of higher temperature situation than these of wood. And yes, now I like to give you some advantages and disadvantages of the material. In this, it's very important to know we have so many different compositions of this material, and all these advantages and disadvantages are depending on these mixtures. So first of all, we have the main advantage. It is the aging stability. It is always in comparison to the single components. So WPC is more aging stability than normal wood. And also we have the reducing of spillability. And for this WPC, we have the main advantage of these. We could influence the mechanical properties of the end parts by varying the profile shape. But there are also some disadvantages. For example, that this material is much heavier than the single work pieces from the separated materials. Like if we have the same part out of wood, it is much lighter than the WPC part. And then we have also the comparatively higher price of the WPC. Now I like to give you a short view on the production process of this WPC, starting with the input of wood, polymers, and additives. Then we have this compounding phase, where it is more often made by these twin screw extruders. There we have the opportunity to extrude the rest of the profile at this moment, but we also can generate WPC granulates and give it into a single screw extruder to get in a new extrusion of profiles, but also could go into the next step of this injection molding to produce complex 3D parts. At the next slide, I like to give you a small video that you can go more in detail of how this process could look like. And after that, Tom will go ahead with the market. Yes. First of all, we start with the mixture, with the compounding of these WPC. There you could see the material out, and then we go into the extrusion phase. In this, it is with an one-line embossing. I think at the moment it's not so nice to see, but there's a texture on the end product, which is by this embossing. And if you like to have an one-line extrusion of this WPC, it could look like this. This is the cooling process of the end material. And yes, the material looks like this. Then we have this cutting and so on. I think this is enough of the process. And now Tom can go ahead with the market. Sorry, Tom, I think we can't hear you.
So can you hear me now?
Yes, now we are able.
Okay, perfect. Yeah, let's talk about a little bit of the market and of wood plastic composites. And firstly, we're going to look at the reasons for demand. So there are several reasons, and one of them being that in the construction industry, there's a growing demand for wood plastic composites products, as well as that the mechanical strength in relation to weight is an attractive point about these wood plastic composites, and a significant growth in the APAC region can be noted. And if we look on the right side, we're going to see the market size in 2021 and the CRAGR index, which is prediction growth in percentage. And so we see that North America is currently the lowest market, or the prediction is to be the biggest market in 2021, but with the lowest percentage in growth on the CAGR index. Followed by that, slightly smaller is the Asian Pacific region, which has a significant size and a significant growth for its prediction, and followed by a smaller market, and lastly is the rest of the world with a high growth but a small share in the overall market. If we take a closer look at Europe, we see that the three countries who make up for almost 2/3 of the whole demand are Germany, Belgium, and the United Kingdom. That's where the demand for wood plastic composite products is especially high. We can take another look at the growth in wood plastic composites by region worldwide again. This time it is forecast till 2027. And we see that it is estimated that Europe is the strongest market by 2027. There is an expected decline in North America and in the Asia Pacific region due to saturation of the market, and a stable growth in South America and Middle East Asia over the course of the forecast. If we look at the products that are mostly made out of wood plastic composites, then it's safe to say that decking is still the most dominating product that is the material is going into. This is followed by automotive interior parts, and then siding and fencing. There are also products that have a really seemingly non-significant slice or share of the whole spectrum, which is technical applications, furniture, or consumer goods like cutlery. These numbers are for the year in 2020 2020, has also to be noted that also the wood plastic composite industry has been affected by the Corona crisis due to supply chains being affected by it. In Germany, it looks similar to the previous graph that regarding the share of products. The construction industry is having the biggest slice of the cake, and this is followed by automotive and industrial consumer goods. If we look at the products, we've spoken about deckings, which is obviously the most prominent application, but there are also other applications, as you can see in the pictures below. Due to what Ronja introduced, injection molding and etc., there are complex shapes are possible. So we see that products like pen caps, or this is a housing for a fan. Here we have a storage container, and on the right we see two applications of where there is a liquid holding container like a bottle, and some cutlery made out of WPC materials. With these materials, something I just noticed during my research for this presentation was the issue of biodegradation. So we spoke about the UV degradation, which is an issue as the material, especially decking, is exposed to the sun. But as we know, wood is also a biological material that is can be damaged by environmental influences. And so if we look at the biodegradation of WPC, it is important to note that the biological rigidity had a lower priority in the overall development process, especially as there has happened a lot in the past years, and there were new technologies and new things developed, so that many manufacturers assumed a certain amount of rigidity already, and many also thought that nothing could deteriorate the material. But WPC is containing a neutral source in form of the natural fibers, and this can be sensitive to microbial decay. So it can happen that you see decay fungi, mold, algae, termites, and more, and has also already been proven on material that researchers looked at, for example, in America, where there was some decking which was not older than 4 years and was contaminated by certain kind of fungus. So how can manufacturers prevent the biodegradation? And we need to consider 4 factors that play a role if you look at biodegradation, or or especially like degradation. So there is firstly the nutrient source, there is moisture, the temperature, and the oxygen supply. I'm going to look at the 3 factors of nutrient sources, moisture, and temperature, and not spend as much look as oxygen supply, as materials like decking, etc., are exposed to oxygen all the time, and of some degree, and it's quite hard to cut off the supply. So some measures include to reduce the access to nutrients for microorganisms. So you could reduce the amount of wood in WPC. So that was the ratio that Ronja mentioned in one of her first slides. It is quite flexible how much wood, how much polymers are added to the mixture. So you could reduce the nutrient sources, but this would increase the practical, or the rigidity. It would reduce would affect the mechanical properties, such as the stiffness, and also it could mean that material costs increase. Another solution that is often thought of is the encapsulation of the wood, so that there is a plastic film around the wood and preventing microorganisms to pass through that kind of barrier. And lastly, what could be also tried is to chemical treat or to do some chemical treatment to the woods, and so that it is like in a constant hydrophobic state. The moisture exclusion goes down a similar path, and the aim is to keep the moisture content of wood plastic composites as low as 20%, as I've learned from some research in that direction. And there are similar ways to achieve the moisture exclusion, similar to the nutrient exclusion. This is the encapsulation, some chemical treatment, or the hydrophobation of the wood plastic composite surface. Yes, so that brings us to the end of our presentation about wood plastic composites. And if you have any questions, we would like to try and answer them for you.
Okay, thank you, Ronnie, and thank you, Tom. So there is a question, please.
Yes, thank you first of all for your presentation. I asked myself how the recycling of this material may happen, because I think plastics are recyclable and also the wood. Are there already some possibilities to do it? Because when you combine these two materials, you would think that you only can burn it to recycle, but are there other possibilities?
I know that.
Go ahead, Ronnie.
Okay, I know that there are possibilities to recycle it, but due to the fact that it's not the topic of our presentation, I don't go more in detail about it, because it's very hard process. As you said, there are two different materials, and it's a little bit hard.
Yeah, so I've actually in preparation to this presentation read about an article of the European Recyclers Association, and they actually pointed out that this is still an open issue. So it is partly advertised as a recyclable material, but it poses quite a difficult situation for the recyclers that to find a process that is, on the one hand, environment friendly, but also at a low cost for the recycle facility. So they expect to have a bigger turn-up of recyclable materials in 10 to 15 years, as this is like the duration of the material. But still, they don't have a very good solution for it.
Okay, thank you for also for this answer. Are there any other questions from the students? No questions. It was interesting, all the presentation, but the story of biological biodegradability was really interesting. You presented different types of possible options in order to improve the resistant, the bioresistant. Do you know if there is one of them which is the most used, or not, or is simply a different option that are already used by the industry?
So I think throughout the research, I'm actually referred to one or two papers that I read about this, but the authors constantly pointed out that there is very little research into that area. So they think that it is very necessary to pursue the research into this direction to make it more rigid to the exposure of environmental factors. But I think, as far as I know, the most suggested topic would be to a chemical treat the wood prior to it.
Yeah, yeah. Yes, this was what I suppose that maybe is the most the cheapest, presumably, but for some reason also the most dangerous, because such chemical substance can be released by the flooring, and this can be a problem for the environment. Okay, and that's I think we can finish here also for your presentation. Thank you again, Ronia and Tom, and we can now go on to the last one, which is number 15, presented by Yoshua, if I pronounce correctly your name, and Jan. Yoshua, okay. and Jan, it's very easy, Jan. And the title is Wood, Past and Present and Future, sorry, as a building material.
Yes.
So please.
Yusak, please ask for the admission first. Okay, then let's dive directly into our last topic. What we chose as topic for today's presentation, we wanted to focus a little bit on the usage of wood in our development of our society. And what are we going to talk about a little bit is the past, the present, and also what is maybe the possible future for wood as building material. So we put up on our agenda a small introduction into the topic, and then we put up 3 main questions which we tried to answer, and that are: what was wood used for, where is wood now, and why we should still use wood. And to start into the topic, Yusa will now make the introduction.
Yeah, thank you, Jan. So in recent years, wood as a building material has become increasingly popular. In the 21st century has been referred to as the beginning of the timber age. While its structures have been built from wood for thousands of years, the 20th century saw a transition towards bricks, concrete, and steel. This was in part because of the strength and durability of these materials, along with increased focus on deforestation. But in recent years, we've seen examples of this trend shifting back towards wood. So one example is the Mjøstårnet. The building that you see in front of you is in Norway. It's actually an apartment building of 18 stories. It is the tallest wooden building in the world, standing at 85.4 meters. So there are many reasons for the resurgence of wooden structures that we will be exploring in this presentation.
So let's first go into the history of wood, and wood was used because it was for the human the first really workable material. So before we had any tools or anything, we were just working with wood and stones and bones to create things. And the first, through the radiocarbon system or dating system, it was proven that the first wooden tools are datable back to 500,000 years. So before we even got the human like we are now, wood was used by us. And you can see it now on the next picture that we have here a structure of a longhouse. It's dated around 10,000 years ago, but actually this photo was taken by a rebuilding team in Germany. Through archaeologists, they recreated big houses, how they were years ago. But for being able to build houses with it, the Egyptians have proven that they used wood as a tool to create their big pyramids, and that is 5,000 years ago, roughly. And you see already that always humankind used it as a tool for building, not only to build with it itself. And this is still up to this point. I think there's no really concrete building without wooden assistance to for the flooring or anything. You have to prepare like the molds and everything, and that is usually done with wood. Also, then we go a far step into the Middle Age, where they combined stone and wood and everything they could gather to buy together to build houses. Before then, in the late 19th and early 20th century, there was a big shift into brick building and concrete building. Some issues with that I will talk about later on. And now, why was it used? I think we have discussed this topic a lot in our module this year and had it in a lot of different lectures, so I don't want to dive into it too much, but it has a really good tensile strength, and if it's used in the proper way and if the proper materials are used. And on the next, you can see on the right side, actually, there was a testing done in California, and they wanted to compare wood buildings to concrete buildings, and especially for the exposure of earthquakes. And what happened is that the result is that the wood has bigger or better properties than concrete buildings, because the wood is able to keep or get along with vibration in itself while keeping its stability, because it's when you think about a tree who's constantly pressured by air and everything, he has a natural resistance against it. Now, where is wood used now currently? There are two main groups. It's the non-structural versus the structural group. And regarding the non-structural, I know everybody knows that we use it as facades and for the flooring and ceiling inside buildings. But what's became more and more important nowadays is that we use it as a forced or a wanted design element inside rooms or with visible bulks. So in that picture, you also can see that there was a shift that we reuse it as a structural element. For example, the framing of buildings, or here we can see a big, one of the biggest wooden buildings in Germany. I think everybody who was at the fair trade in Hanover once will recognize it. It's a really impressive building, and it was the upper floor was entirely built out of wood, but it was reinforced with foundations out of concrete and also with metal strips to keep a lot of pressure inside the material, so it has no possibility to move. The next thing is, and Maria, Paola, and Jana already have taken this topic, and so I don't want to go too deep into the topic of cross-laminated timber, which gives us the possibility to build our future with it. And I think they already said a lot of it. About it, and also they introduced you to the term of engineered wood, where we really take wood as another natural building material besides concrete and steel and everything we know currently. So here's another picture of how it's looking like. I want to point out some major advantages and disadvantages. As we already know, is the lightweight, the insulation. Also, when we produce it locally, it's very sustainable material. When we think about CLT, the size and properties are really a little bit more adjustable. And they are, of course, because we use it for 500,000 years, it's a very known material for humankind. And what is more and more becoming a factor is the high possibility to bind CO2 in our housings when we use wood as building material. On the other side, we have problems with inhomogeneous materials, and also engineers have problems to really good calculate the loads which are applicable and how we must structure it. And that becomes later a role when we think about regulations or law regulations. Also, the vulnerabilities to decay and water, which we all know, still remain. When we think about the Amazonas region, where a lot of logging is happening, and we have a high risk of deforestation, so we have to find a way that we don't take too much wood out of our environment, and also for building. So, to give you just an example, as you may know, the numbers don't play a big role, but you see the trend. And this graph contains the growth of wooden buildings in Germany. And through the last 20 years, you can see a big development inside that. And I think that this curve will even be increasing. And in the following, Yusra will now show us the potential for the future and why we should still use wood. So please take over.
Thank you, Ran. So in the part of why still wood, we've gathered some main motivations that they encourage to use wood in the building. So the most cited motivation for choosing wood, as Jan said, is for sure sustainability. A study had shown that wood systems may replace the equivalent of 1.1 tons of CO2 emissions in comparison of non-wood systems. Sustainability also encompasses good thermal insulation properties, energy-related specificities, and lower heating costs. The speed of building of the structure is the second most appreciated criteria. Timber multi-story buildings can apparently be built in very short periods. There are examples of structures that have been built in just 8 days. So this could be an important advantage in high-density districts to decrease circulation perturbations. And the third most important motivation also concerns cost reductions. They encompass both wood material costs and construction costs. This or the high degree of prefabrication of CLT elements enables fast building times and offers cost advantages. Visibility is also comes up often around the tall wood buildings projects, or for example skyscrapers. For sure, constructing the highest building in the world seems to be honorific for a country or for a city. And last but not least is the lightness of wood structures is also very advantageous, especially when the bearing capacity is low. In some cases, it is the main reason explaining why wood was selected instead of steel or concrete structures. However, there are some challenges and barriers that wood has to tackle in the future or also in the present. There are difficulties related to building codes that includes a variety of rules and limitations, often that prevents the use of wood for building structures. For example, the fire safety or the stability against wind. And there's also the number of stories. There are many countries that maximize the height for wood buildings and authorize only, for example, 6 stories or 7 stories. The next barrier is technology transfer, as well as information and knowledge gaps appear to be also the main barrier and the main challenge, because architects and engineers have regularly not learned how to use engineered wood products. Working with wood is fairly new to many construction professionals and implies more risk and challenges. So there is a huge need for knowledge extension to make wood structures as easy as to work with steel or concrete ones. The third challenge is the maintenance cost. So wood requires a lot of maintenance for sure, such as treatments, repainting, and repairs that are very expensive to retain so that the wood retains its youthful appeal. So because after some years, wood easily weakens due to the environmental and weather changes, and at times this can pose safety hazards if not dealt with immediately. And the last challenges are material durability that is often linked to material performance, which is another constraint, and the availability of the material, especially if we're talking about skyscrapers or really multi-story buildings. And now I will share with you a really exciting and interesting finding, which is transparent wood. Believe it or not, in the future, we might have a house fully constructed from wood, like we can have windows out of wood. So researchers from the University of Maryland have turned ordinary sheets of wood into transparent material. It could become an energy efficient building materials that can be an alternative to glass. So the new study by researchers of the university demonstrate how to make wood transparent using a simple chemical which is called hydrogen peroxide. commonly used to bleach hair. So there will be a modification in the chromophores and a complete remove of the lignin. So, and the empty space, it will be filled with polymers, mainly epoxy. So this chemical modifies the chromophores and change the structure, so they no longer act to absorb light and color of the wood. So we will be having a complete transparent wood. As for the benefits of clear wood or transparent wood, as I said, it can be an alternative for glass. It is stronger, lighter, and more insulating. It is strong enough to be a part of a building because it has really good mechanical properties. It can absorb up to 30% of light. It is more biodegradable, and it can be used in solar cells and solar panels because it is low cost and a renewable material. Now
Yes.
we have the last part with Jan.
Yes, thank you very much, Yusra, for this very interesting topic. But now the question is, where are we heading with wood as a material? As we introduced, there are some challenges, especially when we think about these multi-story buildings and everything. But actually, all the papers we read is there's no really alternative for building, because we are currently experiencing a shortage of building material regarding usable sand and also cement for the concrete production. And when all the sand which is available easily is wasted, we cannot build, or still we cannot go on building with concrete. And also the production of cement is approximately 30% of the, or in general for the building sector, above 30% of the CO2 emissions worldwide. So it's a real big chunk of the whole emissions we have as humans. And so there's no, There's no really alternative to build with it. So also on the other side, we have the possibility to create the right properties for our building materials when we combine CLT with concrete foundations and special modified facades, so that we work against the physical decay of the wood. Also, it must, for the building, be engineered. And for another possibility is on the right side, you see the combination of CLT beams and special connecting systems, so that we are able to strongly combine different CLT parts together. And I think, generally spoken, engineers, we have to work, and also on the other side, the architects, and they have to introduce the wood building more into the market. On the other side, the right law regulations have to be created. And for that reason, there are in every country NGOs working on it. And to find an end to our presentation, I really can only encourage you to research a little bit on your own for this topic, because there's no alternative from my point of view. And to give you a really nice introduction, I recommend the TED Talk of Michael Green, and he talked about why we should build wooden skyscrapers instead of concrete ones with steel. And yeah, thank you very much for your attention, and we are open for questions now.
Okay, thank you to you for this final presentation that is a nice closure. We started with wood and we close again with wood. Very nice. With a sort of summary, because you said a lot about wood, about also research, because what you presented about the transparent wood is something related with the possibility to do also research with this old material. It's old but also new, because we can also invent something with it. And so this is what I really appreciate. In principle, I don't have a question, because you promoted wood, and it's something very close to what I normally do in my life. Are there other questions from the students?
Yeah, I have a
short question. So first of all, thank you very much for your really interesting presentation. You promoted wood as a material and as a renewable material also in the construction sector. What I'm asking myself is if we in the future use more and more wood, especially in the construction sector, do we have enough wood do we have enough wood for higher demands in the future, or can we also get problems with this renewable material?
Yes, thank you very much for this interesting question. And as I said, I only was able to do one sentence in our presentation about this topic. This usage of wood as building material goes hand in hand with renewable and sustainable ways to grow up wood. There's no sense in it, but especially we have to think about that is the only material on Earth with the power of the sun we can really, in the long term, create and build up and manage to harvest in a good way. Especially we have to fight then in this regard the illegal logging and the logging of whole areas and forests. So we need to find a sustainable way to harvest it and to grow it, and then I think we are on the right track. So we have to fight the deforestation first of all, and then we can use more wood.
Yes, I can add something. If we look at the situation in, for example, in Europe, in the USA, or in any case in the North America, the surface covered by forests is increasing. Despite we are using more wood, also here in Italy, the building sector is using more wood than in the past. But in any case, we are using more wood, but the forests are increasing. So, in principle, I think for the next years, there will be no problem to find wood for our buildings, and the cultivation of trees is also increasing all over the world. So in principle, we are in the right direction from this goal.
Especially that wood will be used in the future due to enormous and advantages. So I think there will be a lot of actions to make sure that wood will be available for future uses, especially in the building sector.
Yeah.
There are a lot of NGOs, a lot of organizations that they encourage to use wood, and they do some campaigns how to use it and how. So I think, as you said, we are in the right path to make it available in the future.
Okay. Yeah. Thank you very much.
Okay. So if there are no other questions, I think we can close also this last presentation. Thank you again. Sorry for Joshua and Jan.
You're welcome.
Okay, we are ready to close the course. Unfortunately, this is the last lecture. This is the last moment where we are all together. No, there will be also the test, but during the test we cannot speak, we cannot do anything than the test. So I would like simply to say goodbye to all of you. I really hope that what I tried to share with you was interesting for you, and especially that will be useful for your future. I try to do my best, and I hope that you could appreciate the passion that I have for my subject. And this is the little secret I try to share with you. The little secret to do my work and coming back at home with satisfied. Every evening I'm satisfied because I like what I do, and this is what I can wish for you, to do something that you like in your future, and coming home in the evening satisfied of what you have done. That's all. Thank you for your attention for all this long course, and all the best for your future. Bye bye, and see you for the exam. Please study something before.
Professor, we are still waiting for the football match.
Okay, I'm ready and well trained. So unfortunately, we cannot do by internet. But if you come in Italy during the next years, you are invited here in my institute. Okay.
Thank you very much, Professor.
Thank you, Professor.
Thank you very much.
Thanks.
Bye. Bye.
Bye bye.
Thank you.
Bye-bye.
Thank you.
Bye-bye. Take care.
Bye.
Thank you. Bye.
Thank you. Goodbye.